Hey everybody, welcome to my shop. Today we're going to use a rotary encoder and an LCD to be able to select what color we want to send to an RGB LED. So in this case we can turn it red, we can turn it blue, we can turn the blue on or off, go to green. Let's get started. Let's go over some of the things we're going to need for this project. Of course, we've got our breadboard. We're going to use a rotary encoder. We're going to use a 330 ohm resistor and an RGB LED. This one is a common anode LED. We've also got our Arduino and an LCD. So this LCD is a 4x20, meaning it's got 4 rows, 20 columns, and it is an I2C interface, so we can send all of the information we need over 2 wires, and then the other 2 are for our power and our ground. For the wiring, I'll go ahead and bring up a schematic here, and we'll go through it step by step. We're going to start out with going from our 5-volt pin of the Arduino with the red wire here going to our power rail. We're going to distribute that 5 volts going through this red wire to the VCC pin of the rotary encoder, and also from this wire going from the power rail going this direction and over to our LCD. We also have the 330 ohm resistor. One leg of that is plugged into our power rail. By the way, this power rail here and this power rail here are combined through these jumpers. This one that's slightly discolored down here, that one is separate, and we'll go more over that here in a minute. Next we're going to do the ground pin of the Arduino with the black wire into our power rail, and from the power rail with this black wire into the ground of our rotary encoder, and the brown wire here going over to the ground of the LCD. Now if we take a look at our 330 ohm resistor, we've got one leg going into the power rail, the other leg is going into our common anode leg of the LED. Then the other 3 legs coming out of the LED, our cathode legs, or our negatives, they're going to be our red, green, and blue. And I went ahead and chose red, green, and blue wires just to keep everything straight and easy to see. So our red wire here, which will bring a low signal or a ground to that pin to charge this LED red, that one is going to go over to our digital pin number 5 on the Arduino. Then our green wire for the green leg is going to go over to our digital pin 9 of the Arduino, and our blue wire is going to go over to our digital pin 6 of the Arduino. So also, if you look at the Arduino here, pin 5, 6, and 9, they've got the little squiggly line there that indicates that those have the ability to use pulse width modulation, or PWM. We're not actually going to use that in this video, but in the next video a lot of the wiring is going to be the same and we will be using those. So this is just a way to go ahead and get it set up and ready. As a matter of fact, if you hit that subscribe button now, you'll be notified when the next video comes out. Let's go ahead and go over the rest of the wiring for the encoder here. We've got the orange wire, which is our clock pin. That's going to go over to digital pin 2 of the Arduino. That one is very important because digital pins 2 and 3 on the Arduino Uno are the only ones that are available to use for interrupts. So some of these you can change, like our LED wires, you can change those to different pins if you choose to. You just have to change it in the constants in the program or the sketch. However, these pins, it's very important that you leave those on 2. The yellow is the data pin. That's going to go to digital pin 3. Then we've got our white one. That is our switch pin, and that's going to go to digital pin 4 of the Arduino. Okay, the only wires left are going to be the ones for the LCD. So we've got our 2 wires here. One is going to be a serial clock, and one is going to be a serial data pin. So if you look at the pin out on the Arduino, we have some pins up here on the right. That is digital pin 18 and digital pin 19. They can be used as a serial data and a serial clock pin. But we also have down here on the left, analog pin 4 is actually digital pin 18 and can be used as a serial data. And analog pin 5 is digital pin 19 and can also be used as a serial clock pin. So you can use either or. I'm choosing to use these down here. So we'll start out with the yellow wire here. That's going to actually be our serial clock pin, and it's going to run up to our serial clock or SCL of the LCD. Then we've got the orange wire, which is the serial data pin. That's digital pin 18 of the Arduino, and that's also going to run up to the LCD. So we talked a minute ago about this power rail down here, and that it's not combined with this one and this one. Now the reason that is, I like to sometimes use a different power supply. I may use, instead of 5 volt, a 12 volt, so I have that set up that way. However, in this case, I ran into a situation where I was using the USB, and that was to upload and power the Arduino. So normally when I'm in the shop, like right now, I have this one plugged in. I use a 5 volt power supply that has the capability of 20 amps. So normally that's perfectly fine for everything. But for some reason this time, I went ahead and powered it up, and I'll do that now. So I've got power to the Arduino, everything should be working. But instead we've got backlight on the LCD, but no text. So it's like it's not getting quite enough amperage to do what it needs to do. So what I decided to do is go ahead and use a different power supply. And I'm going to go ahead and plug that in now. I'm going to use a different power supply down on this rail. And because we are using a different supply, we're going to have to share the ground. So I'm going to put a jumper wire from that ground to that one. Okay. And then I'm going to move our power from this rail down to the new rail. I'll go ahead and plug it in. And we'll probably have to reset the Arduino. So I'm going to press the button and reset. And there we go. So I'm not sure how much current it was drawing, but apparently it was too much. So if we take a look at our schematic, that is one change that was made. All of our power on the original power rails, everything else is the same, but I added this over here for the secondary power supply to power up the LCD. Alright, let's go take a look at the code. We're going to go ahead and start out with the title block. Everybody does this a little bit different, but I usually include the name of the file, my name, whoever created it, the date, and the purpose, small little description of the purpose of what we're doing here. So next thing we want to do is go ahead and include our LCD library. So in this case, we're going to include the LCD I2C.h library. If you don't have that already installed on your computer, there's two ways to get this. One, you can go ahead and click this button here on the side, or you can go up to Tools and down to Manage Libraries. Either way, you're going to get in the same place. Then run a search for I2C, LCD, STE, I believe the guy's name is Stefan. So, yep, and you see it down here. So in mine, it says the button is for remove because it's already installed, but yours should say install. Go ahead and click on that and install the library onto your computer. If you want to get more information, go ahead and click the little three dots, and you can go to more information. You can also see some examples once it's installed, but the more information, I believe, goes to a GitHub page where you can get examples and all kinds of information on it. So, all right, so next thing we want to do is we're going to go to, we need to do some defines. We're going to define the LCD rows, which in our case is 4, and the columns 20. Next thing we're going to do, we have to create an instance of the LCD, and I went out on a limb here. I got really creative and called it LCD. So we should be good. We have an instance of our LCD called LCD. Next, we're going to do some constants of type byte. So basically this whole next section is basically calling all of our digital pins on the Arduino and what's wired up to them. So our clock pin from the encoder is going to go to digital pin 2 of the Arduino. Our data pin from the encoder is going to go to digital pin 3 of the Arduino. Our switch pin will be on 4. Our red LED will be on 5, green LED on 6, and blue LED on 9. Then we need some variables, to start with a bunch of integers. So we need something for the encoder position and the previous encoder position. We're going to start both of those out at 1. We need to set some limits. So we need an encoder high limit and we need an encoder low limit. So we are only going to have 3 colors. We have red, green, and blue. So when we're moving the encoder, it needs to choose from one of those three. So our high limit needs to be 3. Low limit, 1. Obviously, we need to be able to select something, so 1, we don't need to go 0 or negative. Next, we need some unsigned longs. We need a current millis, a previous millis, and something to set our delay time of the millis. So it's millis delay time. We're setting it for 5 milliseconds. So these 3 variables, they're going to be used for debouncing our interrupt. Next thing we need is a string variable called direction. This is basically going to store a CW if we're moving clockwise and a CCW if we're moving counterclockwise. We're not actually currently using that in this sketch right now, but it is great for debugging if you need it, so I would have it anyways. We also need to keep track of what state our LEDs are in, so we're going to need a red LED state, green LED state, and blue LED state, and we're starting them all off at 0 or off. So if it goes to 1, it's turned on. Next, we have a section that I've got commented out, and that is for a special character that I created for an arrow pointing up. I also created this special character for a cross. So underneath what we're moving with our encoder is a cross going back and forth to select red, green, or blue. If you're interested in learning more about how to create a special character like this, go ahead and hit that subscribe button. I'm going to be doing a video here in a couple weeks with that. Should be a short video, but it'll go more in depth about how to do that. For right now, just go ahead and copy this code and it'll work. All right, next up is our setup. So we're going to go ahead and start our LCD up. We're going to tell it how many rows and how many columns. Then we need to attach our interrupt. So we're going to use a digital pin to interrupt. We're going to be attaching our clock pin. Now the Arduino is going to look for that clock pin to go low, and when it does, it is going to run the interrupt service routine called have rotation. So if this is all new to you here, this line, highly suggest you watch the video I put out a couple weeks ago. I'll put a link down below and possibly up in the corner here. Yeah, go watch that and then come back. This will all make a little bit more sense. We go much further into detail on this, on how to get the rotary encoder to work for us. Next up, I've got it commented out, but basically we're starting up the serial monitor. Then we're going to do a pin mode. We need to set up our data pin for an input. We need to set up our red LED, green LED, and blue LED as outputs. Next, I have a couple of things here where I was going to create, I've got them commented out right now, but I was creating an angle that points up, or an arrow that points up, and one that is pointed at an angle. So that's these two. Right now, I'm only using the one that I have set up as a cross. I happen to like that one a lot better. So we're going to set up and we're going to create a special character. It's called cross. It uses this here to do it. And I just shrunk that. Yeah. It uses this here. And it's going to call it number 1. So we'll refer to it as number 1 later when we go to create it. So here we're going to have the LCD display turn the cursor off, so there's no cursor, whether it's blinking or just solid in the background. We don't need that. We're going to do some digital writes for our red LED, green LED, and blue LED. We're going to be turning them off to start with. Now you'll notice that this says high, which normally would turn an LED on. But if you remember, we're dealing with an RGB LED that is a common anode, so it's actually reversed. Our common pin is our positive, and our 3 leads that we turn the LED on, or the color on, we need to set those to low to get them to go on. So these are actually turning them all off. Next, we're going to go ahead and tell the LCD to locate position 1, 2. That's row 1, column 2, and then it's going to go ahead and write red, green, and blue. Then we're going to put in our special character, that cross. We're going to put it in row 2, column number 3, and to select which special character we're going to put in, the one that we created and called 1. In our loop function, first thing we're going to do is take a snapshot of millis. That's going to give us our current time. We're going to store that in our current millis variable. So we're going to be using that in a few minutes. Next, we're going to go ahead and take a look to see if the button is being pressed. So every time we go through this loop, we're going to keep an eye on that button. Now, if you remember from the previous video, the button on the encoder is always high. So when we press it, it goes low. That's why instead of seeing digital read switch pin, you see not digital read switch pin. So if it goes low, then we're going to go ahead and run the function switch as pressed. Our next line, we're going to say if encoder position is not equal to the previous encoder position, that's how we know it's moving. So we are rotating. If it is rotating, we want to go ahead and make sure that our limits are being set. So we're going to run the function set encoder limits. So for that, we can come down here, set encoder limits all the way down at the bottom here. If the encoder is greater than the encoder high limit, then we're just going to make the encoder position equal to the encoder high limit. In other words, in this case, we set it for 3. So if the encoder position tries to go to 4, it would become greater than our 3, and it just makes the encoder position equal to 3. Same thing with the low limit. So if the encoder position is less than encoder low, or 1, then it's just going to make it 1. Okay, next thing in our loop, we're going to see if the encoder position is 1. If it is, we're going to clear our LCD, row 2. We're going to clear it of all of our crosses. And we're going to add that special character to the correct position. So in this case, we're going to add in row 2, column 3, we're going to add the special character 1. If the rotary encoder is set to 2, we know now it's green. So we're going to go ahead and clear all the crosses. We're going to set it to row 2, column 10, and we're going to be using again the cross. Same thing with if it's set to encoder position 3 or the blue, we're going to clear all of them off. We're now going to go to column 18 and set our special character in there, the cross. Next thing, we do need to store our encoder position in the previous encoder position so that when this loops through, it knows again if it's moving or not. Our next function is going to be the have rotation, which is our interrupt service routine. So basically, when the Arduino detects that that clock pin on the rotary encoder has gone low, it's going to run this. So we're going to start this out by doing a little bit of a debounce. So we set our debounce, our millis delay time for 5 milliseconds. So that way if it goes low, high, really quick, it's going to wait 5 milliseconds before it actually does anything. If the current milliseconds minus the previous milliseconds is greater than our set time of 5 milliseconds, then it's going to continue on. What we're going to do is, if we do a digital read of our data pin, and it turns out that it is 1, we already know that our clock pin is low. That's what triggers this. So if our data pin is high, we know we're going clockwise. So we're going to increment our encoder. Next, we're going to take a look at the same data pin, and if it's low or 0, then we know the data pin is low and the clock pin is low, so we must be going counterclockwise, and we're going to decrement our encoder position. Then we're going to go ahead and just store our current millis in our previous millis, so that next time it comes through here, it can do a check. The next function we're going to go over is switched press. But before we do that, let's go ahead and review our loop function real quick. So in the loop, we're basically looking to see if the button's pressed. But the main thing that the loop is doing constantly is checking to see if the encoder is moving. If it is, it sets the limits. And past that, it's checking to see where the encoder is. It's going to clear the crosses off and put the cross under the correct color. And it just keeps doing that. So basically the loop is just, once it does that, it keeps looking to see if that button's pressed. Once the button's pressed, we run this function, switch pressed. So inside our switched pressed function, what we're doing is looking at our encoder position. So if it's equal to 1, we know that we're currently looking at red. We're pointing at the red. So we're going to look at the current state of our red LED. If the current state is off, then we're going to go ahead and turn it on by switching a digital right to low. And then we're going to store in our variable, our state, that it is on. So if it was currently on, then we're going to go ahead and turn it off by doing a digital right high. And then we're going to store in our red LED state variable that it is now off. Then we're also going to take a look at our green and our blue. We're going to go ahead and make sure that those are turned off. If the encoder position is 2, we know we're looking at the green LED. If it's off, we're going to turn it on and save it in our variable that it is on. If it was on, then we're going to turn it off and update our green LED state as well. Then we're going to check our red LED and our blue LED and make sure that they're off. Same thing with the blue. We're going to check, see if it's off. If it is, we're going to turn it on and store in our state variable that it's on. If it was on, we're going to turn it off and store that it's now off. We're going to check our red and our green and make sure that they are off. We are going to add a delay down here as a debounce. It's only 400 milliseconds, so although we're pausing the program temporarily for that 400 milliseconds, I don't think that's going to be long enough to affect anything. And that should do it for our program. Let's go ahead and upload our sketch and go take a look at it. Alright, we're back in the shop. We've got our program uploaded to our Arduino. We've got power on, and we should be able to select. I went ahead and propped up the LED or the LCD so that we can see it a little bit better, but we should be able to turn power on or off to any one of these colors and select each color. Works great. So if you learned anything from this video, you enjoyed this video, please give it a like and make sure to subscribe. Got more coming up soon. Thanks everybody. Y'all have a great day.